Hello students, you are given with a traverse details and you need to find out the interior angles. Before we start solving this problem, we will learn what actually this data is all about. Now he gave 1, 2, 3, 4 and 5 sides of a closed traverse. You know closed traverse. What is a closed traverse? Basically, traverse is a principle of compass surveying. Traverse by definition means a series of interconnected lines. In traverse, we have two types, closed traverse, open traverse. When these series of interconnected lines are closing, which means if starting point is the ending point, then that is called as a closed traverse. Imagine a pentagon. Pentagon has how many sides? We have 5 sides for it. The condition is all sides are equal. If any of these sides is not equal, then we should name it as a polygon. Now, A, B, C, D, E, whatever the station points are there, the connected lines is a polygon. If this is a closed traverse, then you need to find out the interior angles of this traverse. Now before proceeding, these kind of problems can only be solved if you know how to plot the diagram. Using these angles, you need to draw the diagram. Now let us draw the diagram. Now AB forebearing is given, back bearing is given. What does it mean to you? It means to you that for AB line, if compass station is set up at A and if you look B, then this whole circle bearing is 150 degrees 15 minutes. And what is back bearing is all about? If you have line AB and if you are looking to A, if your compass station at B, then it is 330 degrees 15 minutes. You can notice that back bearing and forward bearing difference is always 180 degrees. So if this is the situation, then we shall plot it. Now you have to start for any station point and you have to close the traverse. The lengths are not given, doesn't matter, you need to approximately plot it. Now I am starting with station point A. Draw not the symbol is station point A. In the question, it is given that forebearing of AB is 150 degrees 15 minutes. Now if this is station A, this is 0, this is 90, this is 180, so 150 is something like this. You have another point here, E. You never know whether it can be here or it can be here, it can be here. Because you have 3 quadrants, you can expect any line from A. Now how to get that value? Now EA is given to you. Now if I am talking about A to E, it is nothing but EA back bearing. EA back bearing. How to find out AE bearing? EA back bearing is nothing but 300 degrees 30 minutes. So this is the line 300 degrees 30 minutes. Now this is wrong and this is wrong. Now let me say these two are the points now. Now let us shift this station from A to B. Now this is my station B. From B to C, forebearing is 20 degrees 30 minutes. If this is approximately 40, 45, then this is maybe 20 degrees. So let me put a symbol here. Now this is your C. Then from C to D, 295 degrees 45 minutes. So this is 0, 90, 180, 270, 295 degrees. This may be your D point. A, B, C, D and E. So this could be one of the line or this may be one of the line. How to know which line is correct? If you happen to see DE forebearing. DE forebearing is 218 degrees 0 minutes. So it is less than 270. So this is your traversal. So you can shift A from here to somewhere else here. So this is your closed traverse. A, B, C, D. If you don't understand how did I plot this closed traverse diagram, please watch the video again. Now for this closed traverse, we will calculate the interior angles. Now let us take station by station, then we will calculate the interior angles. Now for the first station, angle A is equals to, now if you want to calculate angle A, draw the portion of station A again here. Now you have station A, you have two lines passing from station A. One is to E point, one other is B point. Now these readings are known to you. Look at the diagram. A to B forebearing is 150 degrees 15 minutes. From here to here it is 150 degrees 15 minutes. Now from what is A to E, it is nothing but EA back bearing, it is 330 minutes. So from here to here, this is 300 degrees 30 minutes. So how do I get this total angle? So what I do is, out of 360 degrees, if I remove 300 degrees 30 minutes, out of 360 degrees, out of 360 degrees, I am removing 300 degrees 30 minutes. So the balance is this portion. And if I add this balance with 150.15, then I am getting angle A plus 150 degrees 15 minutes. So what is this answer? You will get this answer as 209 degrees 45 minutes. Now let us calculate angle B. Now let us calculate angle B. Angle B, portion of angle B, you plot it here. You have a line here, then you have a line here. This is going to A, this is going to C, and station is it now. In order to calculate B, you know the bearings from B. That is, from B to C is 20 degrees 30 minutes. So this is 20 degrees 30 minutes. You also know B to A. B to A is nothing but your back bearing. So this is 330 degrees 15 minutes. So how do I get angle B? Right? So from 360 degrees, if I remove 330 degrees 15 minutes, the balance is this portion. So from 360 degrees, if I remove
330 degrees 15 minutes. I'll give the balance this much. So this plus this will give you angle B. And you'll get this angle as 50 degrees 15 minutes. Now how do we calculate angle C? Angle C is given by draw angle C below it. Now this is station C. I have two lines. One is this side, and there is downwards. From C it is D. From C to B. Now do you know the bearings? From C to D is 295 degrees 45 minutes. Now what is C to B? C to B is 200 degrees 15 minutes. 200 degrees 15 minutes. So if I want to calculate this portion, then from 295 degrees 45 minutes, if I remove this, then I'll get angle D. So angle C. So 295 degrees 45 minutes minus 200 degrees 15 minutes. If we do it, then you will get angle C as 95 degrees 15 minutes. Now angle D can be written as, now draw the station D here.
You have two lines, C, E. From D, you know two bearings.
One is from DC. DC. So it is by bearing, it is 115 degrees 45 minutes. Next is DE to 18 degrees 0 minutes. To 18 degrees 0 minutes. So if I remove 115 degrees 45 minutes from 280 degrees, then you will get angle D. 218 degrees 0 minutes minus 115 degrees 45 minutes.
Angle D you can calculate as
102 degrees 15 minutes. Now let us calculate last angle, that is angle E. Draw the angle E. From station point E, I have two lines. One line is to D, and the line is to A. Now, do I know bearings of them? E to A is 140 degrees 30 minutes. And from D to E, from E to D, this is E to D. E to D is given by 38 degrees. So from 120 degrees 30 minutes, if I remove 38 degrees, then I get angle E.
this answer is given by
82 degrees 30 minutes.
Now we have calculated all the interior angles. There is a check in order to calculate or in order to know whether our values are correct or not. Check is sum of interior angles is 2n minus 4 into 90 degrees, where n is the number of sides. Where n is the number of sides. In our case, we have 1, 2, 3, 4 and 5. So this is 5. So what you need to do is sum of interior angles, which means angle A plus angle B plus angle C plus angle D should be equals to 2 into 5 sides minus 4 into 10 into 90. So 10 minus 4 into 90. So 10 minus 4 is 6 90s it is. Check whether our values are correct or not. Now take a look at this problem. In the question, it is given to calculate interior angles. But if you closely observe, these bearings are not whole circle bearings. These are reduced bearings. In spite of that also, we can plot and we can calculate the angles. Now, first part is to plot. Then using plot, we will draw individual diagrams. Then we will try to find out the interior angles. So let us plot this closed traverse. So we'll start with station A. From A to B, it is northeast 45 degrees 30 minutes west. Northeast, it is 45 degrees. This is A. Now this is your B. From B to C, it is 60 degrees. South east 60 degrees. This is south and this is east. This is 40. Then it is approximately like this. From D, so this is C. From C to D, it is 10 degrees 30 minutes southwest. So this is southwest. Now don't put here the symbol, the staff symbol. You need to draw the diagram here, right? So from A to D, back bearing is 75 degrees 45 minutes east. So if this is 45, so from here 75 degrees almost something like here. Now these join at a point. Now this point is your station D. If you have trouble in plotting the diagram, please watch the video again. From the figure, now we will calculate the interior angles. How to calculate it? So we'll start with station A, or we'll start with angle A. We will draw station A separately. This is A, and we have two lines. This is B and this is D. Now we have two bearings A to B. A to B is given as 45 degrees 30 minutes. Now from A to D is given as 75 degrees 45 minutes. So what is the rest angle? From 180, if I remove
these two angles, then you will get angle A. So 190 degrees minus 45 degrees, 30 minutes plus 75 degrees, 45 minutes. If you calculate it, you will get angle A as 58 degrees, 45 minutes. Now let us calculate angle B. Now let us take angle station B. From station B, you have two survey lines, C and to A, and you have two bearings from there, right? So BA bearing is south west, how much? 45 degrees, 30 minutes. Now BC bearing is southeast 60 degrees. Now how do we know angle B? It is sum of these two angles. So 45 degrees, 30 minutes less 60 degrees, 0 minutes. You will get angle as 105 degrees, 30 minutes. Now let us calculate angle C. Now let us take station C. You have two survey lines, one survey line to B, another survey line to D. C to B bearing, north 60 degrees west. This angle is given to you as 60 degrees. Now C to D is nothing but 4 bearing, 10 degrees 30 minutes west. This is 10 degrees 30 minutes west. Now how do I get angle C? 180 degrees minus 60 plus 10 degrees 30 minutes. Now if you calculate this value, you will get the value as 109 degrees 30 minutes. Now we will calculate angle D. Now let us plot angle D. From station D, I have two survey lines. One is to C, another is to A. From D to C, it is nothing but back bearing. North 10 degrees 30 minutes east. This angle is 10 degrees 30 minutes east. Now from D to A is given as 75 degrees 45 minutes west. So this angle is given to you as 75 degrees 45 minutes west. So from this diagram, angle D can be calculated as sum of these two angles. So 75 degrees 45 minutes plus 10 degrees 30 minutes is equals to, if you calculate this value, you will get as 86 degrees 15 minutes. Now this is a closed figure. We have checked sum of interior angles 2n minus 4 equals into 90.
we have calculated angle A, angle B, angle C, angle D. Substitute the values here, and how many sides in our polygon have? We have 4 sides. So left hand side will become 360 degrees, and check whether our values are correct or not. Now, let us plot the traverse diagram. I'll start with A. From A to B is 150 degrees. So, this is 125 maybe. This is B. B is A to B is 150 degrees. Now, B to C is 230 degrees 30 minutes. So, it is more than 180. Okay, fine. So, this is point C. So, it is a clockwise traverse. From C to D is 306 degrees 15 minutes. So, it is more than 270. Maybe like something like that. So, this could be a D. Now, only need to confirm whether the D is correct or not. Now, take it back bearing of it. DC. DC is 127 degrees 45 minutes, which comes in this quadrant. So, that is correct. Fine. Now, E point should be noted. The last point in the traverse should always be checked with previous 2 points. Now, if you are plotting E point, the previous and the before station, you have to draw 2 lines such that they meet at some point, right? So, very important. If you are closing the traverse, the last point should be cross-verified with the 2 adjacent stations, once the previous next the before. Now, we have to draw 2 lines, right, in order to locate our E point. Now, let us draw a line from D. Let us draw a line from A such that they meet at a certain point. Now, from A to E is 229 degrees 30 minutes. It is more than 180 now, right? And less than 270. So, this is the line. Maybe. Now, from D to E, it is 298 degrees 0 minutes. So, it is more than 270. So, now these 2 meet at a point. Now, this is your station E. Now, this can be erased. If you did not understand the plot of this diagram, please watch the video again. Now, using the closed traverse, we shall calculate the included angles. Angle A is given by, if you want to calculate angle A, you need to write down or take the station A, draw the lines, find out the angle. So, how to do it? So, station A, and from station A you have 2 lines. Now, you know the bearings, note down the bearings. This is B and this is
going to E. Now from A to B, you know as A to B is 150 degrees. And from A to E, A to E is back bearing 229 degrees 30 minutes. So from 229 degrees 30 minutes, if I remove 150 degrees, I'll get angle E. So 229 degrees 30 minutes. So we'll write down. So from 229 degrees 30 minutes, if we deduct 150 degrees, we get angle. Say we will write it in this way. So back bearing of EA minus forebearing of AB. Back bearing of EA is 229 degrees 30 minutes minus forebearing of AB is 150 degrees. Calculate this angle. Now we will calculate angle B. Now take station B. From station B you have two lines. One line is going to A, another line is going to C. Now you know these both bearings are not to this and here. BA is 330 degrees. So this is 330 degrees. Now BC is 230 degrees. This is 230 degrees, 30 degrees. Now so from 330 degrees, if I remove 230 degrees, you will get angle B. So what is 330? This is back bearing of AB minus forebearing of BC. That is equals to 330 degrees 0 minutes minus 230 degrees 30 minutes. We calculate it, we will get a value of angle B. Now let us calculate angle C. Now draw station C. Now you have two lines there. One line is B, another line is D. Both bearings you know this bearing and you also know this bearing. So from C to D is 306 degrees 15 minutes. This is 306 degrees 15 minutes because it is both bearing. Now C to B, I'm coming back. So this is right bearing, so 48 degrees. This is 48 degrees. So from 360 degrees, if I remove 306 degrees, I'll get this balance. If I add this, then you can remove it. So what I need to do is 360 degrees minus 306 degrees 15 minutes is forebearing of CD plus back bearing of BC. So 360 degrees minus forebearing of CD is 306 degrees 15 minutes plus back bearing of BC is 48 degrees. Calculate this value to get angle D. Angle C. Angle D is given by, now take station D. Now station D you have two lines. One line is to E and another certain line is to C. Now you should know the bearing of this and you should also be able to know the bearing of this. Now if I deduct from that, if I deduct this from E in this, I'll get exterior angle. Right? So what I need to do is, you can do in that way also. So what? So if I remove this angle from this, I'll get exterior angle. Fine. So how do I do it? So this is DE forebearing. Forebearing of DE minus what I need to know? This is back bearing of CD. Back bearing of CD, and I am getting extreme angle. If I want the interior angle, then what should I do? This shall be divided by 360, right? So 360 minus this angle. So this is same like this. Right? Same came here. This can also be written as 360 minus bearing of BE plus back bearing of CD. And if you write down this value, 360 minus bearing of BE is 298 degrees plus back bearing of CD is 127 degrees 45 minutes. Calculate this value. Now let us calculate the last angle, that is angle E. Now we shall plot angle, we shall take E station. From E station we have two lines. One is to A, another is to D. Now you should be able to know these bearings EA and ED. So from ED, if I remove this EA, then I am getting triangle. So what is ED? ED is back bearing. So back bearing of ED minus bearing of EA. So back bearing of ED is 120 degrees minus bearing of EA is 49 degrees 30 minutes. Now calculate this value. Now we have checked sum of interior angles equals to 2n minus 4 into 90 degrees. Now calculate sum of angle A plus angle B, so on up to angle D, and number of sides in our figure are 1, 2, 3, 4 and 5. I repeat, this is 1, 2, 3 and 4 and 5. So 2 into 5 minus 4 into 90. So if you add all these angles, then you should be able to get 540 degrees. Calculate and let me know whether the angle sum is 540 or not.